Okay, so today's plan is to review chapter six. I think it's probably a good time to just take a short break. We covered a lot of material in chapter six, and also chapter six is a little bit of like a semi-capstone in that it incorporates some new ideas, but also a lot of previous ideas as well. So equation solving steps and some dealing with fractions and factoring uh, to a prime factorization, dividing things out, all of that kind of stuff really kind of comes up in and around chapter six and in the applications in chapter six. And also there's just a lot of application problems, word problems, formulas, things like that. So I think it's good to take, just a little short breather for one class period, do a review of chapter six. These problems should look pretty familiar. They're very similar to problems that we did in class and that you've seen on the homeworks, but just for you to have a chance to kind of check in and make sure that you're understanding the material well, and for you to get a chance to kind of practice in this kind of a setting. So it's a little bit of a pop quiz, but no pressure because it's obviously not being graded or anything like that. But the focus of today is really going to be for you to actually complete these problems, and then we'll go through them kind of quickly. So, what I'll typically do is put a handful of problems on the whiteboard like this, let's say these 5 problems on the screen, give you an amount of time. So for these problems, they're fairly straightforward. So I might say, okay, 5 minutes. And then after 5 minutes, we'll come back, we'll discuss them, maybe take 3 or 4 minutes, go through them fairly quickly. And then if anybody has questions, we can, of course, go a little more in depth and then jump down to the next set of problems and kind of do that. We have, quite a few problems that I have written out. So we'll kind of see how time progresses. But it will be nice to get through all of them and get a nice review of chapter six. And again, kind of reviewing not just the chapter six material, but also even some previous material as well. The quotes of the day today, there are 2 of them. Both are chess quotes, but they are, I think, also applicable to life more broadly. One is from the second world chess champion back in the early 1900s, Manuel Lasker. When you see a good move, look for a better one. And the other current Grandmaster, Maurice Ashley, says there are 3 types of trades: forced, fantastic, and foolish. If a trade is not forced or fantastic, then it's foolish. And I think, and as a side note, for those of you who don't play chess, when you trade pieces, like if I say, okay, I'm going to use my knight to capture my opponent's bishop, and then I'm guessing that they're going to recapture my knight back, so I'm essentially trading my knight for their bishop, that's going to change the look of the game from that point forward. There's no way to undo that trade later on or to say, oh, maybe we'll, take it back or something. So it's a pretty substantial change to the look and feel of the game from that point forward when a trade is made. So I think, obviously these principles apply to chess. That's why these, great chess players have said them. But I think, the applications to life might look something like, you graduate with your degree, you get a couple of job offers. Should you take the first job offer you are offered, or, do you say, well, okay, that's a good offer, but maybe there's something better, right? That's both, that can be risky because maybe, if you don't get back to the folks quickly enough, maybe they pull the offer, but it can be rewarding as well if you get another good offer that comes around. So there are pluses and minuses to that. Or in this kind of sense, well, if you have, say a job opportunity that's out of state, that's a huge risk, that's maybe huge risk, but also maybe huge reward, versus something that's a little more of a sure thing, that deserves some careful thought and analysis, right? One point of view would be, well, take the sure thing, right? Take the lower risk, the known reward, the more conservative option because it's a big life decision. So that's kind of the safe way to go about it. But that being said, if you want to take a risk when you're young, is a good time to take a risk, because a lot of times you have fewer personal responsibilities when you're young. If something falls through, it's you've got plenty of time to kind of turn that around and rebuild. And it's a lot easier when you're young if you need to take a big risk or choose to take a big risk like that. So I think these apply less in black and white to real world situations than to chess maybe, um, but I think the principles are still there that the larger or the more impactful the decision, the more consideration and thought it deserves maybe. Okay, so on to a review of chapter 6. I always kind of joke with review sessions. I'm feeling lazy today, so I figure uh, that I'll let you do the work today. Um, so I'll put these first 5 questions on the screen. I'll also have the chat window up. Let me put that up so that I have that available. There we go. So I have the chat window up. So if you have questions on something, um, you can type in chat. And typically what I'll do is, I'll give you, say, 5 minutes for these 5 problems. This first example, converting some percents into fractions and simplifying, and the second, converting each fraction or decimal into a percent. And typically what I'll do is I'll wait maybe, 2.5 minutes, and then I'll kind of work through these first couple by hand. And then after another couple of minutes, whenever time is up, we'll work through the last half of them. So that way, if you're stuck on one of these, just wait a minute or so, and then you'll start seeing the first couple of steps, depending on the complexity of the problem. Sometimes I'll write out a couple of steps to get you started if you were stuck, or sometimes I'll kind of write out the full problem. So something like this, I'll probably just write out the full answer. So that's the approach that we'll take. So we'll start with about 5 minutes for these problems. Again, if you have questions, if you want to type in chat and I can answer any questions there. Or whenever we kind of come back together in 5 minutes, if you have questions then we can go over them as a group. So let's start with these 5. I'll set a timer for about 5 minutes, and then we'll touch base at that point. So I would recommend, trying to work through these problems, without much extra aid. So, don't be using the calculator on your phone. Don't, try not to refer to your book or notes if you're able to, use this really as a self-assessment of how well you understand this material at this point. And that can maybe help guide your study going forward. If you know that you don't understand the material very well, then yeah, sure, look in your notes. But if you think you understand the material pretty well, try to avoid using notes or other resources and see how well you can do on it. So, think of this a little bit like a challenge in that regard. Low stakes challenge. All right, so we'll start the 5 minutes now, and we'll touch base in 5 minutes. Okay, let's quickly run through these problems. So for the first two, I wrote out the solutions up here. So 34%, we know that percent means part of 100% per 100. So that's the fraction 34 over 100. And we can simplify that. We note that numerator and denominator are even, so we can factor out a factor of 2 from both, divide that out. We get 17 over 50 for the simplified fraction. And we have a number that's a percent, like 34%, that's like 34.0%. To get rid of the percent sign, we shift the decimal point 2 to the left and eliminate the percent sign. So 34% is 0.34. Right, 34% is less than a whole, and 0.34 is less than one whole, so that makes sense. It's always good to check in like that, just in case you accidentally shift the wrong direction. 34% would certainly not be something like 3,400, right? 125% is 125 divided by 100. And we see that numerator and denominator both have a factor of 5 that we can divide out to get 25 over 20. And we still have a factor or another factor of 5 that we can divide out. 25 over 20 simplifies down to 5/4. And as a decimal, 125%, 125.0. So the point is like hiding after that 5. Shift that decimal point 2 to the left. That gives me 1.25 for my decimal. 125% is a little more than a whole, a little more than 100%, and 1.25 a little more than 1. That also makes sense. And then for these next three, converting each fraction or decimal to a percent, well, if I want to put in a percent sign, I shift my decimal point 2 places to the right to make 37.5 and stick a percent sign at the end. So 0.375 is less than 1, it's less than a whole. 37.5% is less than a whole, that makes sense. For 3/4, there are kind of two approaches here, I suppose. One is to go the decimal route, turn 3/4 into a decimal. You might just recognize that 3/4 is 0.75, or you might do long division, 3.00, and then, divide 4 into that, get 0.75. And then we can move the decimal 2 to the right to get 75%. The other way we could do it is we could take the fractions approach. To make a percent, I would like a denominator of 100. I have a denominator of 4, but nicely enough, I see that I can pretty easily multiply by 25 on the bottom to make a 100. And if I multiply on the bottom, I better multiply on the top using my equivalent fractions property. 3 times 25 is 75 over 100, and that is 75%. Either way we wanted to go, if we wanted to go the decimal route or the fractions route, either way got us to the same answer. And 1.27 converted to a percent, 1.27 is a little more than a whole, so I should have a little more than 100%. And indeed, if I shift the decimal point 2 to the right, I get 127%, a little more than 100%, a little more than a whole, and that's what I expect. Any questions on any of these 5 problems? Okay, so let's move down to the next couple of problems here. Let me get rid of a couple of these lines.
Professor, quick question.
Yeah,
So
sure.
when you got 25, right? Is it because you need to find 100? So that's why?
Yeah, exactly.
Okay.
Yeah, because our percent, kind of by definition, is a fraction with a 100 on the bottom. And so I looked at this and I said, well, I can multiply 4 by some number to get 100, and 25 fits that bill. Now, if I had something like, 1/3 or something like that and wanted to write that as some approximate number as a percent, that wouldn't work so nicely because 3 times what gives me 100. Yeah, that's not going to work so nicely. It's going to be like close to 33, but not quite. Um, but because I recognize that 4 is a nice factor of 100, that meant that this going the fractions route was just as feasible as going the decimals route. If it was a fraction that had a denominator that wasn't very nicely able to be made into 100, or even a denominator like 12 or something like that, um, then I would have gone the decimal route and then converted to a percent. Yeah. Yeah, good question though. Any other questions on any of these? Okay, so let's jump down then to applications of percent, and we'll look at two kind of basic mathy examples and two applications. So work through these. And again, try to solve these if you feel confident with this material. Try to solve them without looking at books or notes or anything like that. Try to do the calculations by hand for practice. And, if you're not so confident on them, this isn't a test that's not like unethical or something to look at books or notes, but it's just a little less of a self-assessment if you do that. But it's better to take a quick glance and then be able to do the problem than to just, sit there looking at the screen. Because these first two should go somewhat quickly, but these next two a little bit longer. We'll take about 10 minutes or so for these, and probably about 5 minutes in, I'll write a couple of notes on here to give you a little bit of a hint if you're stuck somewhere. So we'll touch base in about 10 minutes. 5 minutes, I'll write a few notes, and then 5 minutes after that, we'll come back together and work through the answers. So we'll come back at about 10:51. Okay, let's work through the answers to these. So the first one, we see that what number is 6% of 240? The is kind of clues us into an equal sign, and of typically suggests a multiplication. And that does make sense. X is 6% times 240 does kind of make sense with this question. So we want to multiply 6% times 240, or that's 6 over 100 times 240. Well, we know that 240 is 240 over 1. So this is 6 times 240 over 100. We can divide out a factor of 10, I suppose. That's 6 times 24 over 10. And let's figure out what's 6 times 24, or 24 times 6. 6 fours are 24. Oh, jumping the gun. 6 fours are 24. 6 twos are 12 plus 2 is 14. So we get 144 over 10, or this is 144 like 0.0 over 10. The over 10 says move that decimal point 1 to the left. I think this should be 14.4. Our 240 is in dollars. And we can ask ourselves, does that make sense? Well, 10% of 240, that's 1/10 of it. That's like $24. 6% is like 2/3 of ish of 10%. So what's 2/3 ish of $24? Is that $14? Yeah, that's pretty close. So that makes sense, right? If we had gotten out $144, we maybe forgot to divide by that 10 or something. Then we'd have said, wait, if I'm looking for 2/3 of $24, something in that ballpark, somewhere around $16, that's not $144, right? Something went wrong. So this does make sense as an answer to this question. I was trying to find a good way to do this and I really couldn't. So let me just move my text and my next questions down a little bit. So when I hit enter, uh, the types text moves, but the written text doesn't. So let me just recombobulate this a little bit here and give us a little more, oops. Okay, there we go. Give us a little more room for this next one. I'm trying to get all of them on screen at the same time, but then also want to write on top of them. And all right, there we go. So 38 is 25% of what number? The what number, the thing we're looking for, of course, we call that the variable name, say X. And 38 equals 25% of some number X. What number is that? Or 38 equals 25% times X. Or we see that X equals 38 over 25%. That was a pretty messy looking 38. What's 38 over 25%? Now, I guess I could make this 0.25 and make it 3,800 over 25, but maybe I could take a little bit of a shortcut here and notice that 25% is 25 over 100. But 100 is actually just what, 4 times 25. So the 25s go away. This is just 1/4. So I could go this route. That's perfectly fine, but it's maybe not as efficient as saying, well, uh, 38 equals 1/4 X. So X equals 4 times 38, multiplying both sides by 4. This is a little quicker. Either way is going to work. This is maybe a little more efficient. I can come over here and do 38 times 4. 4 eighths are 32. 4 threes are 12 plus 3 is 15. So we get 152 as our answer. Does it make sense that 38 is 25% of 152? Well, 25% or 1/4 of 160 would be 40. Yeah, that makes sense. So 25% of 160 is 40, 25% of 152, a little less than 160 is 38, a little less than 40. That makes sense. So I feel confident with this answer. Any questions on these two? Okay, on to our two word problems. So for this first example, when Hiro and his coworkers had a lunch at a restaurant, the bill was $50.20. They want to leave 20% of the total bill as a tip. How much should the tip be? Well, the tip should be 20% of 50/20, 20% times $50.20. Now, again, there's a couple ways I could do this. I could say 20% is 0.20. I could do 50.20 times 0.2 and go that route. I might be able to be a little more efficient here, though, mainly because 20% is a pretty nice number. There's a couple ways I could go about this. One way, maybe we'll do it in blue, would be to recognize that while 20% is just 2 times 10%. And 10% of a number, 10% times some number, just moves the decimal point 1 to the left. So 10% of $50.20 is $5.02. Right? That 50.20, the decimal point moves 1 to the left. That's what the multiplication by 10% or 1/10 does, giving me 5.02. And if I double that, $5.02 doubled, that gives me $10.04. That will be one way to do it. That's kind of leveraging the decimal side of things. Or we could kind of leverage the fraction side of things and recognize, well, 20% is 20 over 100. I think that's just 1/5. So it simplifies down to a pretty nice and simple fraction. Or this is, well, 1/5 of $50.20. That's like if I had 5 $10 bills, 1/5 of that is one $10 bill. So the number of dollars gets divided by 5. $50 divided by 5 gives me $10. And 20 cents divided by 5 is going to be 4 cents. Either way, I get to $10.04, whether I kind of want to take the decimal route or the fractions route. I could, of course, like I said, I could definitely do this. This would work. Just the straightforward, convert the percent into a decimal, make it 0.2, and carry out the multiplication. That would certainly work. You would get the same answer, $10.04. Maybe a little more efficient to do it one of these two ways, though. Any questions on that one? Okay, and then our last example here, Charisse deposits 6% of each paycheck into a retirement account. Her last paycheck was $1,300. How much did she deposit into her retirement account? And then as a little extra bonus, I think a lot of us have heard of employer matches. That's a benefit that a lot of employers offer, that if you deposit, say, $2 into your retirement account, your employer will deposit an extra $1 alongside you. So they'll often give you a 50% match, as fairly typical these days. So her employer will deposit $1 for every $2 she puts in. What's the total amount deposited this month? So let's figure out, what did she deposit, what came out of her paycheck, and then what was the total amount between her and her employer that got deposited into her investment account or her retirement account. So Charisse's deposit is 6% times 1,300. So that's 6 over 100. times 1300. Well, these factors of 100 divide out, and I just have 6 times 13. 6 times 3 is 18. 6 times 1 is 6, plus 1 is 7. So we're saying that Charisse deposited $78 into her account. Does that make sense? Well, let's say, 6% is maybe half-ish of 10%. 10% of $1,300 is $130. Is 78 like half-ish of 130? Yeah, pretty close. So it makes sense. It's in the general ballpark we're looking for. If we ended up with $780 or like $7.80, well, something went wrong. And if Charisse's employer is depositing $1 for every two that she deposits, the total deposit is going to be 1.5 times what Charisse deposited. It's her amount plus half that amount that's coming from her employer. I did phrase this in terms of a ratio because we've talked about ratios and proportions at this point too. So we could think of it a couple different ways. Or I have 6 over 100. 1.5, I guess I'll make that 3 halves. That'll probably be a little easier to deal with. Times 1300. I see the 100 divides out with the factor of 100 and the 1300. So I have 6 times 3 times 13 over 2. And the 6 has a factor of 2 that can divide out, making 3 times 3 times 13. And then, whoops, my 2 divided out. So this would be what, 9 times 13. Let me do that up here. I could, of course, just take 78 times 3 halves or something, but 9 threes are 27. 9 ones are 9 plus 2 is 11. So that's one nice thing about an employer match is if you're contributing to your retirement account, this $78 up to 117, this extra, what is that, $39? That's kind of like a $39 bump in her pay for this month. Now, of course, she doesn't see that in her paycheck to be able to pay rent or something like that. But that's, money that ultimately is going to be hers, that's in her retirement account. Any questions on either of these problems? So really the first part of this problem was kind of the standard question, then this was just a little bit of an extra bonus piece. And as an aside, when you're evaluating, what employer to work for, wage and salary is extremely important because you can't, pay your current bills with investments in your retirement account, or yeah, I guess you can, but not so easily. It's quite complicated to do that. But benefits like this are an important part of the compensation package. So things like in retirement matches, what types of retirement accounts they offer, what types of health insurance they offer, all of that kind of stuff. What kind of paid leave policies, pregnancy leave, things like that. All good things to consider when looking at a job offer or a couple of job offers and weighing them against one another. Right? There are always going to be trade-offs. Okay, let me see if I can fit a little more of this on one screen here. Let me just get rid of some of this extra white space here. All right, so we have one question on percent change. And I'll try to put these definitions right about there where I think you can still see them. So talking about a raise in hourly pay, find the percent increase. We have a question on sales tax here. And a question on commission. So I know these are a bit scrunched up, but we have 3 questions, one there, one here, and one there, along with a bunch of definitions that are on the screen as well. So for these 3 questions, let's again take about 10 minutes. And so we'll touch base at around 11:16. And again, roughly halfway through, 4, 5, 6 minutes in, I will jot down a couple of notes to get you started if you're stuck on one of them. And then at about 11:16, we'll come back together. Okay, everybody, let's work through the solutions to these three. Um, so I jotted down some notes here. Let me do the same thing I did before. Just start by giving myself a little extra room. Uh, there's not a super good way for me to do this at the outset, so we'll just move this text down just a little bit. And the same with this one. What do I need to do here? I think I did the same thing I did last time. There we go. All right. Okay, so for this first one, we have the percent increase is the new amount minus old amount over old amount, or that's $17.38 for new pay minus the old pay, $15.80, divided by the old pay, $15.80. Now we can do this subtraction, in decimals. We can do the same old decimal subtraction. If we're thinking of money, though, we can think like 1738 is, well, that would be $15.80 plus. If I added a whole dollar, that would bring me to 1680. I can't add another whole dollar. 1780 would be too much. So then I could add, but that would take me to 1680. I could add 20 cents to take me to $17 and then add another 38 cents, right? If you were making change at a cashier station or something, this is probably how you would do it if for some strange reason somebody paid you $17.38 for an item that cost $15.80. Or if you ever, watch the tellers of the bank count out money, this is essentially how they do it. So we can see that 1580 plus $1.58 equals 1738. So 1738 minus 1580 is $1.58. So taking the thing we're subtracting off, kind of adding the whole number amounts to get up to as close as we can get, then adding, adding whatever we need to get to make it up to the next whole number, adding however many cents, and then adding however many cents we need on top of that to make it up um, to the full number. And here we might realize 1.58 over 15.80, that's 1.58 over, well, 15.8 is like 1.58 times 10. We can actually divide out this strange factor of 1.58. It works out really nicely here. This gives me 1/10, or 10 over 100, or that is a 10% increase. It's a pretty nice increase in pay, 10% increase in pay. Any questions on this one? Okay, next up is a sales tax problem. Let me actually just delete my definitions here to give me a little more room. So, sales tax problem. We have a refrigerator, its purchase price was $730, and the sales tax rate is 8.5% of the purchase price. Find the total cost. So we first have to find how much sales tax we owe, and then we have to add that on to the purchase price to make the total cost of the refrigerator. So the sales tax is the tax rate times the purchase price, 8.5% times 730. Or I can do that as 8.5 over 100 times 730, or that's 8.5 over 10 times 73. So I'll do 73 times 8.5, 0 decimal places, 1 decimal place there. So I'll have 1 decimal place in my answer. And 5 times 3 is 15. 7 fives is 35. Plus 1 is 36. 8 times 3 is 24. 7 eighths are 56. Plus 2 is 58. I get 6205 for the answer, and I want one decimal place, so 620.5. That's still divided by 10. I still have my over 10 here to deal with. But all that over 10 does is bump my decimal point one more place to the left. So this is an intermediate answer. This is the amount of tax that I owe. And then my total purchase price, sorry, the total cost is the purchase price, 730 plus the tax, 62.05. Or I see that that is 792.05. So the total cost, $792.05. Any questions on that one? Okay. And again, that passes the reasonability check. 8.5% is a little under 10%. 10% of $730 is, say, in the ballpark of $70. I'd expect to pay about 730 plus 70, or about $800 for this, and 792.05. It's pretty close to 800. So it seems reasonable. Okay, and then our last example in this section. Nevaeh is a cruise specialist and earned $111 commission after booking a cruise that cost $3,700. What is her rate of commission? So here we're using that the amount of commission equals the commission rate times sales. And we can solve for the commission rate as 111 divided by 3,700. Now I do want my commission rate as a percent. I would like to say such a percent, 5%, 10%. So I'll choose to think of this as 111 over 37 times 1 over 100. This is the bit that I'm kind of cordoning off that's going to become my percent sign, my per 100. And then I'll simplify 111 over 37 separately. And I actually see this 37 doesn't go into 1 or 11. How many times does it go into 111? Well, 37 times 2, well, that's going to give me 74, right? It's like 35 times 2 plus 2 times 2. 37 times 3, well, that would give me 90. 30 times 3 plus 7 times 3, 21. Well, wait, that's actually exactly 111. So I actually note that 111 over 37 is just 3. Or this is just 3 over 100, or 3%. So I protected that factor of 100 in the denominator to leave me with percent at the end. Right, it would be kind of a pain to try to do 111 divided by 3,700. That would be, a bunch of work. I'd have to append a bunch of zeros and all that. And I would end up getting 0.03 and then have to convert back to a percent. But I realized that I already had this nice factor of 100 in the denominator that I want to use for a percent anyway. So I'll just, keep that off to the side. Any questions on any of these three examples? Okay, so one more example up here in the rates section. And then let's see if we can fit. Can we fit all of these on the same screen? I think we can. Like the train, right? I think I can. I'm going to end up regretting this when I have to move a bunch of my text later on, but there we are. All right, so first question on rates. Hiroshi bought a lawnmower for $175. original price 250, find the discount rate, and then 4 questions on simple interest. I think maybe what we'll do is we'll plan to do maybe these first 4. We'll touch base in maybe 10 minutes or so. Um, and then, if you're working ahead, if you're ahead of the game, start on the Tom question. If you don't get to the Tom question, no problem. We'll kind of also lump that in with the next couple of questions down here as well. So, so if you're a little bit ahead, but by the time we're 7, 8 minutes in, start on the Tom question. Otherwise, not a big deal. So this will be kind of like a bonus question down here for this round, but work on these 4 questions, the Hiroshi one, and then the first 3 simple interest ones. Work on those. Take about 10 minutes. Like usual, I will write a few notes at maybe about 5 minutes or so in. Let me give myself a little more room here. There. I'll write a few notes at 5 minutes or so in and give you a little bit of a hint. So yeah, we'll come back at about 11:37 or so. Okay, let's work through the solutions of these four problems. So the first one up here, we see we want to find a discount rate. So he bought the lawnmower at a discount at a price of 175 when the original price was 250. So the amount of the discount is 250 minus 175. He paid $75 less than the original price. So that was the amount of discount. The discount rate then is the amount of discount divided by the original price, or 75 divided by 250. And I see that there's, I guess, a factor of 5 in the numerator and denominator. I see there's even actually a factor of 25 in the numerator and denominator. So 75 is 25 times 3. 250 is 25 times 10. So I could start chipping away with a factor of 5, or I could recognize the full factor of 25. This gives me 3/10, or 30 over 100, or that's a 30% discount rate. So he bought this lawnmower on sale at 30% off. Any questions on that one? Okay, so the next one, find the simple interest earned after 5 years on $600 at an interest rate of 8% per year. This is a straightforward application of the simple interest formula, I equals PRT. So principal times rate times time. So we have 600 times 8% is 8 over 100 times 5. And I see the factor of 100 divides out with the factor of 100 in the 600, giving me 6 times 8 times 5. And I guess I can do 5 times 8 is 40. 6 times 40 is $240. So the simple interest earned over 5 years on a principal of 600 at a rate of 8% per year would be $240. Now the next two examples, we are not looking for interest, we're looking for something else. So we're going to have to solve an equation. So for this one, find the principal invested if $224 in interest was earned in 2 years at an annual interest rate of 7%. So the interest is $224. The principal is the unknown, so I'll leave that in there as P, an annual rate of 7% for 2 years. So that's R times T. Or I see that 224 equals P times number. P equals 224 divided by that number, that coefficient of P, 224 over 0.07 times 2. Or I might choose to write this as 224 over 2 divided by 0.07, or another way of saying that, 224 over 2 divided by 7/100ths. 224 divided by 2, that is just 112. And then that's multiplied by 100 divided by 7. I invert and multiply. Now I am a little curious, does 7 divide into 112? Let's see, it would be nice if it does. So 7 goes into 11 once. 1 times 7 is 7. 11 minus 7 is 4. Bring down the 2. 7 does go into 42 6 times. Nothing left to bring down. 0 remainder. 112 is 16 times 7 times 100 divided by 7. My 7's divide out, and I'm left with $1,600. So to earn $224 in interest over 2 years at a rate of 7%, the principal would have had to be $1,600. That would have had to be the amount invested. Any questions on this one? I chose to take a more fraction-based approach to this one, just to show a little bit of variation, remind ourselves how to divide fractions and so on. But several different ways to compute this answer. And then for the last one in this group, find the annual rate of interest. So we're looking for R here. If a principal of $2,600 earned $468 in interest in 6 years, in other words, 468 equals 2,600 times R, what we're looking for, times 6. Or solving for R, we divide by 2,600 and we divide by 6. So R is 468 divided by 2,600 times 6. I'll write that a little bigger. I noticed that I have this 2,600 on the bottom. I probably want to write my rate as a percent at the end. So I'm going to kind of cordon off that 1 over 100 that's eventually going to turn into a percent sign at the end of all of this. Now, if I look at 468, well, I see that that's an even number. I can write that. Well, let's just come off to the side here, do a little bit of scratch work. OneNote was being slow, letting me choose my blue marker, but there we go. Let's do some scratch work. 468 over 26 times 6. I see that 468 is an even number. So 468 I can write as 234 times 2. And 6 I can write as 3 times 2. And I can divide out that factor of 2. Just keep chipping away at it. 234 is also even. So it's going to be 115. So 230 over 2 is 115. Plus 4 over 2 is 2 more. So 115 plus 2 more gives me 117 times 2 over, and 26 has a factor of 2. So that's 2 times 13 times 3. We can divide out another factor of 2. 117, well, I noticed that 7 plus 1 plus 1 is 9. 9 is divisible by 3. So therefore, 117 is divisible by 3. Let me figure out what that is. 3 goes into 11 3 times. And 3 goes into 27 9 times. So 3 times 39 gives me 117. And I could divide out the 3's and keep going, or I might actually recognize that 13 times 3 in the denominator actually is exactly equal to 39. So they divide out, leaving me with just 3 from this part. So coming back over to here, this is 3 times 1 over 100, or 3%. So the interest rate, the simple interest rate is 3% per year for this investment to turn out the way that it did here. Any questions on any of these? Okay.
Professor, how did you get the 117?
Yeah, good question. So 234 is 117 times 2. So I could have either recognized that 234 is even, and then just come over here and do 234 divided by 2 and get 117. Or I could recognize that, well, 234, that's pretty close to 230. And 230 is like 115 times 2. And then I would have to add an extra 4 on top of that, which is 2 times 2. So 115 plus 2 gives me 117. So either way, I could think of it a little more heuristically. That's a little quicker. Or I could definitely come over here, do the long division, and get 117. So this 234 turned into 117 times 2. Any other questions? Okay, so we've got about 12 minutes left. So I think maybe I'm going to get rid of this question and maybe get rid of this question. So we'll take about 5 minutes, take a look at these three questions over the next 5 minutes. That's probably a little aggressive of a time frame, but see how far you can get through in 5 minutes or so. And at about 11:52, 53, we'll come back and we'll work through the answers. So 5, 6 minutes, and then we'll come back and work through the answers. All right, so in our last few minutes here, let's work through these problems. I don't think I need to shuffle too much here. So for the Tom choice, if he sells the mutual funds, takes that $8,000 out of the investment account and pays off the car loan with that, what would he lose and what would he gain? Well, he would lose the 9% interest per year that he would have gotten from the mutual funds if he had left that invested. He loses that amount per year. That's a detriment if he sells them and takes the money out. On the other hand, he gains the amount that he would have paid, the interest he would have paid to that car loan. He gains that 17% per year. So he gains 8,000 times 17% and loses 8,000 times 9%, or that's a net gain of 8,000 times 17 minus 9%, or a net gain of 8,000 times 8% per year. Or that's 8,000 times 8 over 100 per year. That's 80 times 8, or 640 per year. And how much per month is that for him? Well, that's 640 over 12. I know that 12 times 5 is 60, so 12 times 50 is 600. And then 12 times what would give me 40? I guess 12 times 3-ish, 3 point something, gives me 40. So about $53 per month. So he would save about $53 per month. He'd be better off, at least strictly mathematically speaking, selling the mutual funds, taking the money out, paying off the car loan. Now, there are things to consider like taxes. We have to pay long-term capital gains tax for selling the mutual funds. Things like, is he going to be disciplined enough that when he pays off the car loan and gets, whatever, maybe this $250 a month bill that goes away, will he take that 250 and divert it back into savings, or will he spend it on a big TV or something? So that's a it's a more complex problem than simply the numbers, but at least you know what the trade-off is. The trade-off is you're paying $53 a month to keep this $8,000 isolated in investments instead of using it to pay off the car loan. Okay, down to this next problem. If we want to solve this proportion, I know I'm going a little quickly here. We've only got 4 minutes or so left, but stop me if you have questions. Solving this proportion, we cross multiply. We get 7 times q, multiplying both sides by q, equals negative 14 times 16, multiplying both sides by 16. Or q equals negative 14 times 16 over 7. I see the 7 in the denominator cancels with with the factor of 7 in the 14, leave me with a factor of 2 there. I'll kind of do this in shorthand notation like that. This is negative 2 times 16, or negative 32. So the ratio 7 to 16 is equivalent to the ratio negative 14 to negative 32. And then lastly, April wants to paint the exterior of her house. 1 gallon of paint covers about 250 square feet, and the exterior of the house measures approximately 1,600 square feet. How many gallons of paint will she have to buy? And we'll answer this question kind of completely mathematically. Again, we discussed some of the nuances with the actual decision making last time. But we set up our units. We use dimensional analysis here. We have gallons per square feet on both sides. 1 gallon of paint covers 250 square feet, and we want to know how many gallons of paint to cover 1,600 square feet. So 1 over 250 equals x over 1,600. We cross multiply. 1 times 1,600 equals 250 times x. We divide. X equals 1,600 over 250. We can divide out a factor of 10, 160 over 25. And I notice that this is 150 over 25 plus 10 over 25. It is 6 plus a little bit. Well, plus 2/5. So we should buy 7 gallons of paint. We'll use 6 full gallons, at least we estimate we'll use 6 full gallons plus a little bit, plus 40% of the next gallon. But if we only bought 6 gallons, we would have a section of house unpainted. So we need 7 gallons. We need to round up, even though 2/5 or even though 0.4 is less than half, we're not going to round down because then we'd have a bit of house unpainted. So we'll round up, even though this 2/5 is a fairly small amount of paint, we still needed to cover that last little bit of house. Any questions on these last three or anything from today? All right, so hopefully that was a good review of a lot of the tools and techniques, as well as applications and word problems. We ran into a lot of word problems in this chapter, and I know that's something that folks sometimes like to see a couple of times to get comfortable with. So hopefully this gave you another opportunity to look over some of that. When we come back, we'll shift gears a little bit into chapter 7, talking about real numbers, the real number system, rational and irrational numbers, and some more ideas related to properties like commutative and associative property, etc. So that is the plan for next week. I'll end the recording. As always,